right? Because next week is the project fair. And I tried to explain that in the email as well. So that's why I shifted it up a week. You guys are welcome to come to the project fair, by the way, next week.
I probably won't because my brother's
Isn't that a reason to go? Like,
not for him.
what's your brother's name?
Connor.
Connor McNabb. I didn't know about your brother. Okay, yeah, I don't think he did either.
I believe that was when. So when I did software engineering, we had to take both modules.
Mm-hmm.
I don't think he actually did both modules. I think he did.
Mm-hmm. He missed the good one. He missed it. That's a pity. Okay, yeah, I will try to record this demo and upload it so that everybody can see it. Let's see. Next seminar next month, by the way, I'm going to also show how to do that. So how to record your own videos, edit them, upload them to YouTube, shock the world with them. So for this one, I need to do a screen recording. Okay, so let's do a Tableau demo. Have you guys tried Tableau?
Yes.
You tried it for the data viz module. Did you try it?
Yeah.
Not yet. Oh, okay, some more last minute attendees. I wasn't going to pass this around, but since there are some more people here, I'll pass this around. Which department are you guys from?
Physics.
Physics. Okay, good. Good. So you'll like. I think you guys are going to like this. So nobody brought their laptop, but if you did bring a laptop, you could follow along. If you want to follow along some other day, the data we're going to be looking at is on my webpage actually. So if you can find my webpage and then click data, type data, and then cars, and then UK, you can find the data that we're going to visualize online. So it's a data set of car accidents in the UK with a special focus on Wales. No, just in the UK car accidents, all the registered or reported UK car accidents in the year 2015. Right? And I just found that data, that's public data, it's supplied by the UK government, so you can download. The UK government opens up lots and lots of data, so you can just download that. I just Googled car accident data with latitude and longitude, and I found some different data sets. This is one of the data sets that I found.
So it's geospatial data.
Yes, it has latitude and longitude coordinates, so we can use the geospatial capabilities in Tableau. That's one of the reasons I chose it. And this is the software we're going to demo. It's Tableau. There are different licenses. One is a commercial license, which we don't use. One is a student license, which is free for students. And one is a public, Tableau Public, which is free for everybody. And that's what we're going to use, Tableau Public today, but you can download the Tableau student version or whatever you like. And let's see if I can find the data that let's have a preview of that, if I can find it. So if you open it up in Excel, this is what it looks like. Right, this is typically what you might use to look at data in a spreadsheet. Now, Excel, this data set is bigger, so it's 140,000 accidents. So there were roughly 140,000 car accidents reported in the UK in the year 2015. Which is a big number, but the real number is bigger than that, right? Everybody know why the real number is bigger? What? Does anybody here drive a car? Why is the real number of accidents bigger? Dylan?
People is not towel.
Exactly.
It's not reported.
That's right. This does not include the unreported accidents, right? Because a lot of people don't report their accidents because it causes insurance premiums to go up, right? So this is 140,000 accidents. I just did some back of the envelope maths. So that's 384 per day. That's 16 per hour. And that means one accident every 3 to 4 minutes, which is kind of a lot, right? I actually have a theory that driving is unnatural. This is part of the evidence because there are so many accidents. People just are not meant to be operating machinery generally that's traveling at those speeds. And it's an interesting topic too because it's one that nobody talks about. Car accidents and car fatalities and things like that, even though it's so common, right? In the US, there were 30,000 deaths due to car accidents in 2015 or 2016, something like that, in a typical year, which is a lot, right? 30,000, that's the population of a small town, disappearing in car accidents every year. So it's a lot. So this is what the data set looks like. Every accident has an accident ID. It has some location easting OSGR, location northing OSGR, latitude, longitude, a police force that handles the reports, an accident severity, which is a number from 1 to 3, the number of vehicles involved in the accident, the number of casualties, the date, the day of the week, the time of the accident, the local authority district, local authority highway, and more variants. Road type, very interesting. Speed limit on that road, the junctions, junction control, lots of, actually quite a detailed report goes into these accidents, right? Pedestrian crossing information. Another thing about the lighting conditions, the weather conditions, the road surface conditions, special conditions, lots of data here. So very thorough data collection exercise. So that it would be interesting to know how much money it costs to collect all that data. I don't know what all the fields mean, but you can look at this spreadsheet to find out what all the different variables mean. Right? This is car accident circumstances, vehicle variables, casualty variables. There's the police force identifier, the accident severity identifier, the day of the week identifier, the local authority district identifier, and so on. Right? So we're not going to have time to look at everything. We'll just have a little introduction. And one of the challenges with looking at this data when I was downloading the data, there were some comments by some people who downloaded the data. You could make a comment like about anything you learned or whatever you wanted. And one of the comments was, I just tried to visualize this data in Excel and only 1/3 of the UK showed up. Does anybody know why? Anybody happen to know why that could happen?
Is that the Excel limitation?
Yes, Excel has a limit, right? Not all versions of Excel can actually read in 140,000 records. So some versions of Excel, it only reads 50,000 records, so which is roughly 1/3 of the data, right? So there are better options than Excel for visualizing this kind of data, and that's what we're going to see right now. Any questions before we start? So that's Tableau Public. And that's the starting screen. And I can import different kinds of files, right? Instead of saying importing a file, the terminology in Tableau is to connect to a data source. So the data in this case is in a CSV file, right? Because a CSV file doesn't have those hard limits of how much data you can store in them. Is the physicists familiar with the CSV format? Comma separated values. It's a text format. Each value is separated by a comma. So here I'm going to connect to a so-called text file. And there it is, Accidents 2015 CSV. And then hit open. So there it will show me the different columns, and it will try to derive some information about the data in the columns. So here, Tableau has determined that this column is a set of strings, right? That's what this ABC means. That's the accident index. And this is identified as a number, and that's what that pound or that hash symbol means, right? The data in this column. Location northing is also a number. So latitude and longitude are special, and they have a little symbol there that sort of resembles a globe. And that means Tableau has identified these as latitude and longitudinal variates, which are very nice for visualizing the data on a map.
So would Tableau be able to use the northerns and the easterns as well?
I don't know. I don't know if that would be possible. My guess is that you would have to convert it to latitude and longitude. There are tools, and you might remember from the DataViz module, there are tools that will let you convert different kinds of data to latitude and longitude. For example, there are online tools that will let you convert postcodes to latitude and longitude. So usually there's a workaround. There's police force. Accident severity. I'm going to change the day of the week to a string, if I can find that right here. Instead of a number, I'm going to change it to a string. We could change some other ones to a string, but for the purposes of this demo, I'm going to change that one to a string because it's not really a set of data necessarily. It's just an identifier. And 1 is a Sunday in this case. You can look that up on the metadata spreadsheet that we just looked at. So that's importing the data, right? There are all the different columns, right? I'm scrolling back and forth. And then I'm going to create a worksheet, which a worksheet is the canvas on which we actually start creating visualizations, for example. So it has to do some work because it's importing the data, which takes some time. Right? I don't know how many megabytes it is, but it will eventually finish importing the data. So there's a worksheet. Actually, I just want sheet 1. So these are all the these are all the columns, right, in the spreadsheet, right? The first row number, second row number, accident ID, the date, the day of the week, and so on. These are the things we just looked at, but now they're arranged on the side, right? So we'll try starting out with something interesting. So we can double click on latitude and longitude, for example. So there's latitude. I can double click on that and then double click on longitude. It's not very exciting so far. And that just brings up the geospatial data, and it's the average latitude and longitude of all the car accidents. Very exciting. Right? If we want to see each car accident, for example, we can drag the accident index, which is the unique identifier for every single accident, to the so-called detail. Assuming I know how to use the mouse and the touchpad and everything like that. So it asked me a question if I really want to do this because there are so many of them, so many accidents, and yes, I want to do that. So the field being added may contain as many as 140,000 members, and the recommended maximum for this shelf is 10,000. We want to add all members, actually. So then I get some more, sort of the first visualization of the accidents. By the way, if there are any questions or anything like that along the way, feel free to interrupt me. And I can zoom in on the map, right? I can pan around. And I can drag the mouse over any of the accidents and get the details, right? The accident ID, the latitude and the longitude. I can keep zooming in if I want, right? Probably everybody wants to see Wales, for example. So that's a lot of accidents, right? If I want to improve that, I can drag the accident severity to color, like if we want to add some color. So the accident severity is here, and we can color map the geospace or the accidents. Remember, 1 is the highest severity, right, involving fatalities, and then 2 is middle, in the middle, and then 3 is not so severe. It's chosen a continuous green color map by default for this data. We can change that, right? Would be kind of nice to change it to 3 distinct colors. So let's do that. So let's choose there are lots of different color mapping options here, right? So let's just choose something like red-green diverging, for example. And rather than a continuous color map, we'll match it to the number of accident severity classes. So rather than 5, we'll just have 3. So now we can see, okay, the severe ones, the middle, and the minor accidents map to the different color.
So is one the most severe or the least severe?
1 is the most severe, yeah. I chose red just because kind of seems like red is severe accident, right? And now we can get some idea, a little bit better of the visualization of the different car accidents. And we see that where the severe ones are. We can see kind of a big group of them right in London, which is not too surprising. Right, and this, to me, I'm not sure what city that is, but we can zoom in on it. And we can also change the size of the dots. So right now, all the dots are the same size, so all the ellipses are the same size. But we can change the ellipse size depending on the number of casualties. That would be kind of fun, wouldn't it? So the greater the number of casualties, the bigger the ellipse size. So there's the number of casualties. And then we can map it to size of the ellipsis. Right, and then it looks even more informative. Right, so we can zoom in, and that was quite a big jump actually. There's quite one I see right here is quite big, right? This one looks really bad, right? Accident severity 1, number of casualties 7. So there was a really big accident there in 2015. Right, we can pan around looking for other ones. It reflects pretty much the density of roads, right, in the UK. So we can get an indication of where the road network takes us a little bit from this. But this could make an entry into the researchers' art competition, right? Just the simple thing. It would be a lot better than some of the entries that are already being put in there. So we can also change the size. We can modify it with an interactive slider, right? So if we want to make the dots bigger or smaller, we can do so. Lots of accidents. And we can put in our favorite postcode as well. We can search the map based on postcode. So we're all wondering about SA2, for example. So that's what the map of SA2 looks like. I don't understand what this is. I think this is an error.
Airport.
What is it?
The airport.
Oh, that's the airport. You're right. Well done. Well spotted. It looks funky. I thought it was an error the first time I saw it. That's the Swansea airport. That's right. There aren't many accidents at the Swansea airport. We can change the size of the glyphs a little bit to make them a little bit more visible. Right. Anybody have a postcode that they want to enter? Liam, where are you from? Which postcode?
CM37.
CF37? CF37. That sounds... Is that in the Cardiff? That's not the Cardiff neighborhood, right? Okay. So not too many fatal accidents in that area. CF37. Okay. That's... I don't recognize. So that's okay. That's north of Bridgend somewhere. Hmm. Hopefully, one of these is not you. Anybody else want to see a postcode? Their favorite postcode? Dylan?
What's the big dots and down towards the bottom?
This
The
one?
grey one.
Oh,
Yeah.
this one.
Severity 2. Severity 2
Oh,
casualties.
that's
20.
crazy.
Yeah.
It's a boss.
That is crazy. I didn't notice that before. Number of casualties 35. Yeah, maybe that was a bus accident.
Yeah.
A car crashing into a bus. That can happen. It's not very common, but yeah, that's really surprising.
To say, so medium severity.
I think you have 35 casualties.
I didn't even notice that one. And then we can we can do, so we can, for example, click on day of the week. If we wanted to just for example, look for all the accidents on a, I don't know, a Sunday or something like that. So right now all of them are being shown. One is a Sunday in this case. Sunday's going to have, well, we don't know, but I'm guessing.
Another big one there.
Where was the other big one? This one?
Yeah.
That is funny. I didn't even notice that one.
It's another one, I think. It's 124.
Oh, it's the same one.
That
Or
was
not.
It's not the same one. It's 55.
Okay. Any other good ones? That one's kind of big. There's another kind of big one. That's the only... I suppose it could have been a train too, but that's not very common.
It's
Maybe
car accidents.
severity is not, how severe it is for people, but for traffic or something.
Yeah.
There's a pretty big one.
And if there's 24 fatalities, but they
No,
drove off,
fatalities.
into the city, and not be severe for the traffic, that people slowing down.
That's like Port Talbot area, right? Something like that.
Um,
I think is Bridgend like right here. That's like Swansea, Neath, Port Talbot, something like that. That could be Bridgend actually.
no, it's
Right, so we can click on different days of the week if we only want to focus on a special day of the week. Anybody want to guess which day of the week has the most accidents? Saturday. I'm going to leave you in suspense for a few minutes. So we can name this sheet, by the way, we can give it a name. For example, map. Pretty exciting name. And we can create some other ones. So for example, that's an exciting bar chart to answer the question like which day of the week it's the most hazardous, if we want to know. So we can drag day of the week to columns, maybe. And then we can drag the number of casualties to rows. So where is the, okay, number of casualties to rows. And we get a bar chart. So it's Friday, actually. The most hazardous day to drive.
Sundays.
Followed by, yeah, Saturday's
I
not
guess
bad.
Yeah, people are just saying.
And then the other question is, well, when on Friday? Right. Anybody want to guess?
Morning or evening.
So you can with all of the visualizations, you can do some sort of on mouse over action to get the details, right? So, day of the week, number of casualties 21,000 on the Sunday, compared to almost 30,000 on this Friday. And the rest of the days these days are pretty evenly spread. It's actually increasing every day of the week, with the exception of Saturday for some reason. It's kind of a little bit mysterious. So Tuesday, okay, Wednesday is slightly less than Tuesday, at least for 2015. Right. So we can name this sheet, for example, day versus casualties, yep. And we can do another one to find out, for example, when people are getting into accidents. What are the guesses? Again, when did
Afternoon 6.
morning,
Afternoon.
afternoon? Any specific time? What?
Oh, 3.
3 o'clock?
Evenings, I think, like 6, 7.
6,
Yeah, 5, 6.
5 or 6? Dylan?
About the same from six.
Any other guesses? Anybody here ever been in a car accident? Okay, that goes to show how common it is. Okay, so let's try to find out when. So there is a time somewhere. There's so many variables here that it takes a second to find them. Time to columns. And then we can drag number of vehicles to rows. Number of vehicles. And we get the number of vehicles over time. And that's midnight, right? That's kind of, oh, those are null values. That's midnight. And then it drops to 4 a.m. So that's the safest time to drive, 4 a.m. maybe. I guess in terms of accidents. The first peak is at 8 a.m. Now, these times have been rounded to hours, by the way. They're not showing the minutes. And then it dips at 10 o'clock. And this is the thing that surprised me a little bit, that starting at 10 o'clock, there's a steady increase, right, already from 10, starting at lunchtime and then peaking at 5 p.m. I wouldn't have, if I was going to predict this, I would have thought that the curve would peak at 9, for example, and then dip down like this, like a double bell curve shape.
I'm not surprised that it goes down from 5. I would have thought.
Oh, I see. Mm-hmm.
I would have thought people would be going on for longer than that.
Mm-hmm.
There's more people going home, but then, still higher than 10 o'clock. That's
So
Yeah, but not 3, 4.
it sort of looks like that Friday at 5 o'clock is the most dangerous time to drive. So we'll do a little more investigation. This one is going to be time versus vehicles. Add another sheet, and this will give us a little bit more detail about that situation, when the most dangerous time to drive is, which day of the week. So we can double click on time here, and then we can drag the number of records to row. So number of records is just the number of accidents in the database. a row. And that gives us the same curve again. We can also drag, for example, the number of vehicles to road. Right, so it's flexible. Where's the number of vehicles? Right, we get 2, for example. We don't really need 2, it's a little bit redundant. So,
Yeah.
what's that?
That's similar, not the same.
Yes, yes.
Can we do it on the same axis?
We'll see, we'll see. So let's remove the redundancy.
I think you can just drag it on the plane.
Now, if we want to get the days of the week in there, we can take day of the week and drag it to color. And that gives us more information. So this is a cumulative. Anybody want to guess which day of the week is the most dangerous? Well, we already know. So those are the days of the week. Oh, I forgot to turn off my phone. So this is Sunday, so the blue line is Sunday. So Sunday is like the safest time. It is. They do sort of follow a very similar pattern though, except for Saturday and Sunday. All the other ones have a very, very similar pattern. So on Saturday, the noon time is the peak. And then on Sunday, it looks like 1 o'clock and 4 o'clock are the peaks for driving accidents. And for all the days, 4 a.m. 4 a.m. is the safest time. It's a good time if you're trying to get your 6 a.m. flight out of Cardiff Airport. Anybody have one of those before? 6 a.m. flight out of Cardiff. And we can experiment with different kinds of visualizations, right? So there are the different kinds of visual designs. So Tableau offers a bunch of different kinds. So we can also visualize this as a area chart. I don't know if everybody's seen area chart before. I think everybody that took the data viz module has, but not everybody else. So this stacks each day of the week by area. But I don't, okay, so that's, okay, this is the going backwards. So that's Saturday, Friday, Thursday, and so on. So it's Sundays at the top. I actually I mean, this is aesthetically appealing and everything, and I do like it, but I think I prefer the separate lines for each day of the week. And you can experiment with the different kinds, like a matrix, different kinds of matrices. These are not enabled. Right, a pie chart matrix, a bar chart matrix. That's a nice one. So it's like a stacked bar chart. And other kinds of bar charts, bubble charts. Right, we don't have time to go into all of those into detail. These are, physicists like these with the error bars, right? The physicists think that the computer scientists are crazy for not having error in all of their visualizations, and there's a good case to be made for that. Bubble chart and so on. So you can experiment with the different visualizations there. And we'll call this sheet days of week, for example, versus vehicles. And there are more features, so we're not going to just do another visualization next. There are visualizations, there are things called dashboards. Dashboards is a very kind of, I don't know, trendy word these days. Has anybody seen a dashboard before? Dylan has. Anybody else? A dashboard is something that the industry loves to talk about, creating a data dashboard, which we're going to demonstrate next, but it's a combination of different views together. Very, very common. So to create a so-called dashboard, there are the other options. That's the worksheet, that's dashboard, and then new story. We won't have time to really go into the story today, but we'll do a sample dashboard. And the dashboard is pretty cool. I do think it is cool. So what does a dashboard look like? So the user interface has changed quite a bit. All the rows and columns have disappeared, and this interface has changed, right? And there are our previous views, right? So to create a dashboard, we can just drag these views. First, I'm gonna set the layout to automatic. We could manually adjust the size of each piece, and that's fine, right? By choosing a different option, like range and all that stuff. Or we can just choose automatic. So we can drag the map to the dashboard. And then we can drag day versus casualties, for example, over. And we can drag days of the week versus vehicles over. And now we have something that resembles a dashboard. I'll make that, see if what happens if I make that a little bit bigger to use up the screen space. The screen space starts to become an issue when we're looking at dashboards. So we can still interact with any of the views, right? But we can also connect the views, right? So let me see if I can, okay, I can make that disappear, right? So I can, for example, I can take this one, and there's a filtering option. It's hard to see, but that's the shape of a little funnel from your kitchen or whatever, wherever you use funnels. And you can choose use as a filter. And now we can click on, for example, Friday, and then all of the views are synchronized and linked together to filter. So these are all the accidents on Fridays. In the U.S., the U.S. has a problem. I don't know which other countries have this problem. Maybe the U.K. too. But there's a lot of drinking and driving on Fridays in the U.S., especially Fridays and Saturdays. What is that? Did we already look at that big red one? Yeah, there's another one. You wouldn't expect a big accident out here. So we can turn that on and off. We can check, for example, Thursdays and Sundays, right? We can turn that off so it's no longer a filter. Use as filter. And to get, to create some more screen real estate, for example, we can get rid of the titles. So I think there are other ways to get rid of the titles, but that's the,
There's high.
yeah, I saw the hide option. So hide title, for example. And we used one of the views as a filter. We can rename the dashboard, for example, death by driving. And we can also add a title to the dashboard if we wanted to use it in some sort of a presentation. For example, if you were trying to sell something to somebody or something like that. Where did the title go? Edit texts. I don't know where it went. The first, oh, there it is. I should be able to click and drag that somewhere to get it into a good place. Let's get rid of that. Get rid of that one too. But you can add a nice title on top, right? If you want to. And then you can publish your results on the web, for example. So there's my title, Death by Driving. You can see there are lots of different user options and controls here. It takes time to get to know the user interface and all the different options and all the different controls. There are quite a few, right, hiding everywhere. So there are menus hiding in here, right, in each view, and then there are more menus here hiding, right, and more menus at the top. There are lots and lots of different user options here, which we don't go over, right, because it takes a long time. But we can publish this data if we want to on the web, so save to Tableau Public. And you can enter an email address and password. And I don't remember mine. Let me think. I don't think that's correct. Yeah, I forgot mine. But anyways, you can then take the results and publish them on the Tableau website, and it will make a copy of this whole dashboard, and you can look at it in a web browser on the Tableau website, which is quite interesting. You know,
Is that interactive then?
it is interactive. It doesn't have as many features as the desktop application, but it is interactive. Yeah, and you can see I have done a few examples before that I have successfully uploaded when I had my username and password working properly from other demos you can find there. Yeah, that's the basic introduction to Tableau. Any questions, comments? It's a very complicated piece of software, but it's also has an amazing set of options and more advanced options than a typical piece of software that you're probably using now. For example, I think the physicists maybe are using R sometimes, or MATLAB, right? So R and MATLAB and things like SPSS, they do have some very nice visualizations, definitely. The difference here is that this is interactive visualization, so you can modify the visualizations while you're playing with them. Whereas usually in those other packages like Excel and MATLAB and R, there's no interaction. So you write some script, you hit run, and then you get the visualization, something, some output, and that's it. And then you can rerun it over and over again, modifying the input. Any questions or anything? Okay, we'll stop there then. So next Thursday is the Computer Science Project Demonstration Fair. You're all welcome to come to that. That's why we're having this seminar today, because I'm going to be organizing that and running that next week. And then in a month from next week, we're going to have the last seminar, which is how to use visual media to publicize and support your research, right? So I'm going to show you how you can use all of your existing software and hardware to create videos and put them on YouTube, for example. So you don't buy anything nothing additional. You're just using what you already have, and you're using free software. Right? That's going to be a fun one, and I think most people don't know how to do that actually, and it's quite valuable in my opinion. Right? Good. I think I was supposed to say, may the 4th be with you.